Okay, guys, so last week they would give us the masses of the two isotopes and the percentages, and then we just had to turn the percentages into decimals, swoop them over twice, multiply it, add those, and we got the atomic masses that we see on the periodic table. So remember, what's on the periodic table is an average of all the different isotopes that are out there based on their percent abundance. Okay, now it's going to be a little bit different. They're going to give us the total from the periodic table. They're going to give us one of the isotopes, but we have to figure out the info from the other isotope. Okay, so I did this in color because I wanted y'all to see that once you have this formula and you know the formula, all you have to do is once you multiply out what you can, there's a subtraction and a division. You always subtract to get x by itself, you divide to get x by itself, okay? So out of this whole formula, there's only gonna be one unknown, that is our x. Okay, so the atomic mass of helium on the periodic table is 4.2060. Okay, so that is this number over here. That's what's at the end. So isotope 1, isotope 2, what is the total? That's this first thing that they give us. So this first number that we know we're going to have to use is 4.00260 atomic mass units. Okay, there are two isotopes. So this is the info from the first isotope. This is the info for the second. They will always give us the info for the first, but we don't know the second. So I just wanted to point that out. Okay. There are two isotopes for this element. The first isotope has a mass of 4.022 and a percentage of 80. Okay, y'all, they're talking about the first isotope, so we put that over here. So our formula, it's going to be the mass of the first isotope times the percentage divided by 100, okay? So they gave us the mass, 4.0022, and we multiply it not by the percentage, 80%, we have to convert it, divide it by 100. How do I make 80, how do I divide 80 by 100?
Move it up 2.
So it becomes just 0.8. Remember, 0.8 is the same as saying 0.80. This one does have an extra significant digit, but we're not doing those right now. Okay, so that's our first parenthesis. So that is isotope 1. And then isotope 2, we don't know. So this is the deal. We don't know the mass of that first isotope, so that is our x. But we do know the percentage. So remember, I'm going to do it over here. Isotope 1 percentage plus isotope 2 percentage has to equal 100%. So if they told us isotope 1 was 80%, 80 plus what equals 100%? 20, is she right? So if the first isotope was 80% of abundance, they occurred 80% of the time, what must the second one occur for it to be a total of 100? 20. If you need to do it on your calculator, it's 100% minus 80. That gives us 20% left. So what is the abundance of the other isotope? It's 20%. But how do we convert 20% into our decimal divided by 100?
Move it up 2 decimals, right?
Good. So it's x times 0.2. Y'all, sorry, that decimal looks terrible. 0.2 equals 4.00260. I'm not going to put the units just so that it's less stuff to write. Okay, and before we get into the first thing, let's actually do what's in the parentheses. So ready? On your calculator, what's 4.0022 times 0.8?
3.2017.
Okay, plus, y'all, what's x times 0.2? 0.2x,
Yeah.
good. So it's just 0.2x. And then that's equals 4.00260. Okay, so this is where we're at now. I'm just gonna box it in with yellow. So this is where we're at right now. Okay, so we have 3.20176 plus 0.2x equals 4.00260. Our goal is to get x by itself. Easiest thing to do first is, number one, subtract. Y'all, what am I subtracting? Remember, I'm trying to get x by itself.
3.2.
Good. So the first thing to do to get x by itself is get rid of that on this side of the equation. So on this side of the equation, to get x by itself, we got that. Perfect. We have the minus from both sides. So it's minus 3.20176. This ends up canceling out.
Yeah, that cancel out.
Okay.
Then
Minus.
bring down to 2.
Y'all. Yeah, I'm just gonna, maybe I'll try to do it in a different color. Green. Subtract. So we minus 3.20176 minus 3.20176. I'm gonna go back to black. Okay. This cancels out. When you have 3.20176 minus this, that cancels out. So then on this side, we're just left with 0.2x equals, what's 4.00260 minus 3.20176?
Is 0.80084.
Okay. How do we get x by itself now?
Divide.
Perfect. New color. Divide to get x by itself. So we divide by 0.2. We divide by 0.2. Okay. Anything on the top and the bottom, if it's the same, becomes a 1 and it cancels out. So these cancel out. Awesome. X is now by itself. And your answer is whatever that is right there.
4.0042.
Good. And we'll bring back our units. Atomic mass units. Boom. Okay. So once we properly sub in, we sub in what they tell us the end amount is. We sub in what the isotope 1 mass and percentage is. We know what the isotope 2 percentage is because they must equal 100, so we're only left with one unknown. Once we multiply that out, we know we're going to subtract first, then divide. Okay, so let's do this for the question number 2. Let's do problem number 2. Y'all will have to do the rest 2 on the back side. Okay. Okay. The atomic mass of neon on the periodic table is this. That means that that's the end 20.1798 atomic mass unit. Okay. There are 2 isotopes. That means I have 2 big brackets. Okay. The first isotope has a mass of 19.99, and a percentage of times 95.5%. We don't know the second one times. We need to figure out what the percent is. Okay, so after reading this, the atomic mass of neon on the periodic table is this right here. That's our end amount that we need to get to. There are 2 isotopes. The first one has a mass of 1999 and an abundance, a percentage of 95.5. We know nothing about this other one, but yes, we do. Okay, we know that the abundance, this number plus this number must equal 100. So ready? Isotope 1 So isotope 1 is 95.5 plus what gives us 100%. So I'm going to do 100 minus 95.5 equals 4.5. So this other one right here is 4.5%. 4.5%. Okay, but before we can do any math, we have to get rid of the percentages and move the decimal over 2 times. So ready? I move this over 1, 2. So it becomes 0.955. It's no longer a percent. Okay, and I move this over 2 in front of the 4, and then I need to add another 0.
0.045.
Perfect. So this first one is 0.045. 19.99 times 0.995. Ooh, no. When you multiply this out, this first number is 19.89005 plus, when you multiply x times 0.45, it's 0.045x equals 20.1798. Okay, over here in red, first thing I'm gonna have to do is subtract. Second thing I'm gonna have to do is divide. It's the same for all of them. Okay, so what am I gonna subtract? 19.89005 from both sides. I'm trying to get
20.
perfect. Subtract 1. I'm gonna do that in a different color. Subtract 19.89005 from this side. Subtract 19.89005 from this side. Okay, when I subtract it from this side, it cancels out. And I'm just left with 0.045x equals 20.1798 minus 19.
I got it.
What'd you get?
0.28975.
Absolutely. Okay.
Then we divide.
Yep, because we subtracted first, now we divide. Let me get my red pen out. Divide by 0.045. 0.045. That's going to cancel those two out. Divide by 0.045. Okay, so then I'm left with x equals
Got 6.4.
yeah, this don't seem right.
I got this.
Yeah, that's this. I have an error somewhere. Boom, boom. 20.1798 minus 19. Did you still get 19.89005?
Mm-hmm.
What'd you get?
19.09045.
Yeah, that sounds right. 19.99 times 0.955. 19.99 times 0.99. Oh, that's maybe what we did. Yep, I think I did 0.995. Okay, it's not that big of a deal. It's just this number that we got right here was a little bit off. That is 19.09045. So then when we do 20.1798 minus 19.09045, this actually gives us 1.08 0.935. Then when we divide that by 0.045, now we get 24.20777777. 1, 2, 3, 4, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 8 AMU. That's what you got, Sarah?
Yes, ma'am.
Okay, yep. So as you can see, you have to, number one, put your knowns in the formula. You know this second one, you never know. Okay, you're not gonna get 3 or 4, I'm only ever gonna give you 2. And then you get this percentage by saying, okay, 100 minus that percent gives me the rest of the abundance. Okay, try number 3 and 4 on the back. Substitute in what you need, but before you do any of the big math, let me know. So it's okay if you do this math to get the other percentage, but before you start doing all the other math, let me check this formula right here, okay?